Okay, so we're going to really quickly talk about multiplication models. We're doing this as a group instead of individual groups because I looked over the packets and there are some things that I really quickly need to talk about. First of all, with the packets, when you were going through them, there are a couple different things that I saw constantly that I said not to do yesterday. There are also some packets that did a really nice job of showing two different strategies that they're supposed to use. So, the first strategy that I told you not to use is do it in your head. Okay, I know that these questions are easy. I made them easy for a reason. I know that you can do 7 times 3 in your head. So I don't want you to write 21. Okay? For the most part, people didn't do that. There were a couple people that did, but then you also did 2 other strategies. The other strategy that I don't want you to do right now is going to be, if it's 7 times 3, you're writing literally 7 times 3, line 21. That's the same thing as doing it in your head. Okay? For tougher problems, I will let that be a strategy. So when you have 2-digit times 2-digit or 3-digit times 2-digit, I will let that be a strategy because then you're actually carrying numbers. You're actually looking at base 10. But in this instance, 7 times 3, you're not doing any real math on paper. So I don't want that to be a strategy. And I would say 75% of people did that as a strategy. So you need to go back, erase that, and change your strategy. Okay, you're going to be using one of the strategies that I'm giving you here. So, first strategy is going to be pictures. So we talked about almost all of these yesterday. There is one different one that we didn't talk about, so I'm just going to fly through them. This is on the website under multiplication strategies, so you can watch it. You're only going to use pictures for smaller numbers. Obviously, otherwise it's going to take you way too long to do it. If you have 28 times 35, you're not going to draw 28 sets of 35. That's going to take you a whole day to do. Okay, it's just a waste of time. So you wouldn't use that strategy in this case. But for smaller numbers, or for 7 times 3, this would be a good strategy to use. So the example I gave you is Susie is making 4 cookies for each classmate. She has 10 classmates. How many cookies does she have to make? So I made cookie trays, 10 cookie trays, and I made 4 cookies on each, and the cookies aren't really lines. Yes? Are there? Okay, so I actually messed up. I'll add another one, no worries. I'm glad you caught me on that one. But essentially, drawing the picture is very easy to do. If you have numbers, if both numbers are greater than 10, I would probably say this isn't the strategy to use. If one number is around 10, one number is less than 10, it's a really easy strategy to use. And you don't have to make really in-depth pictures, as you can see. I just put lines in boxes. Pretty easy? Alright, the second one are arrays. All of you know how to do these ones. We showed it yesterday. It's, again, you use it for smaller numbers. You don't want to use it for huge numbers. So if you have 2 sets of numbers that are going to be both double digit, I probably wouldn't do an array because that means you're drawing over 100 dots or 100 items. It doesn't make sense to do. Okay, so this is, again, used for smaller numbers. So my example for this one is Jake has 4 pencils. Marissa has 3 times as many as Jake. How many pencils does Marissa have? So I have 3 sets of 4 to equal how many? 12. Okay, so this is another example of some of the questions on the first page of that packet. This would be a very easy way to do it. Okay? Third one is called repeat addition. You know this one as well. Some of you did this in your packet. I like to see that. I know that 7 times 3, 7 plus 7 plus 7 is still going to be easy math that you're doing in your head, so you're not doing a lot of math. But that's an example of one that you're still showing me the work that you're doing. So if you were to use larger numbers, let's say 7 sets of 20, and you don't know the answer to that, you can keep adding 20 that many times. Okay? So, this can be used for larger numbers. It's up to you. You're probably not going to do it if both numbers are going to be larger than, let's say, 20, because then you're going to basically write 20 times, and that just gets repetitive. Okay? It's very long. So the question I use is there are 28 students in each class at STEM. There are 6 classes on our floor. How many students are there in total? Okay, so I used a large number, but I didn't use it a large amount of times. So 28 plus 28 plus 28 plus 28 plus 28 plus 28 is 156. Make sense? Okay. Next one is called anchor facts. This is one that you probably are familiar with, but you didn't know what it was called. So you're going to use the math facts that you know to answer questions. You can use this for any amount of number. When you get good at it, you're going to be able to do this in your head, and you're going to be able to do it for very, very large numbers. It all depends on your fact knowledge though. If you're not good at multiplication, rote facts, so if you're not good at multiplication tables, this is going to be difficult for you. So multiplication tables are something that you can work on. If you want me to, I can either create flashcards or I can give you a table so you can practice that, because that's going to help with all your multiplication skills. So with this one, the example I used is John eats 8 cookies for 12 days straight. How many cookies does John eat? Some of you might know the answer in your head already. Okay? But what I did is I broke it down into facts that I already know. Instead of having 12, because 12 is an unusual number, I said 8 times 10, which means that there are 2 sets of 8 left, so then I added that here. Okay? So 80 plus 16 is 96. Yes? What's that? Oh, sorry. Okay. As you can see, teachers make a mistake at 6 in the morning when they make these slideshows. I appreciate it. But you know what I'm saying. Okay? The next one I used is going to have larger numbers. So most of you could probably figure out 8 times 12 through different math strategies. It's a low number, but that's one that you could definitely practice with this. But the next one, if Steve runs 26 miles, so a little less than a marathon, at an 11-minute mile pace, how many minutes did he run in total? So 26 is an odd number, 11 is an odd number, so I'm going to use 25 and 10 for my first one. Unusual number. Okay? So 25 times 10, I know that that's 250. Easy for me. Then I know that there's one set of 25 that's left here. So I went 25 times 1. Oops, and that's wrong too. This is wrong. It should actually be 26. There's one set of 26 that's left. And then the last one should be 1 times 10 because there is one set of 10 minutes left. Okay, since I was using sets of 10 instead of 11. So what it should have been is 250 plus 26 plus 10. Are you calling out something that I made a mistake on? Okay. You can do it the other way as well. Yep, and there were 2 ways to do it, but I thought this one would make more sense to you. So that's actually, originally I was going to do it this way, but it's easier to explain it that way. Okay, very good. So does everyone kind of get where I'm going with anchor facts? Yeah. So they're facts that you are anchored in, so you know how they work, you know what they are based off of your rote memorization, and you're using things that are more simple to you. Is 26 times 11 harder than 25 times 10? Yes. You probably couldn't tell me off the bat without looking at the answer on the right side what 26 times 11 is, whereas 25 times 10 you can definitely figure out. Connor?
So it's just an order of operations algebra?
Sort of order of operations, but you're actually breaking it down into the order of operations. Okay? Because originally there isn't an order of operations. Originally the problem is just saying 26 times 11. But you're going to break it down into subsets and create the order of operations. Okay? Yes?
There's also an 11 against
Okay. Or you could skip count. Either way. You could look at it and say 25 is very close to, or 4 times 25 is 100. 12 sets of that would be 300, and then you can subtract the difference. Okay, so those are different base facts that you know. You can use multiplication, you can use division, you can use subtraction, you can use addition. Any of those facts that you know that are going to help you, you can use for anchor facts. Oh.
If you go back a slide, I remembered a mistake. Because it was like 28 times 6 is 156, 58, I think.
No, it's 168.
168.
Yeah, that's okay.
I did say it.
Ladies and gentlemen, I'm just going to say this. I said this the last kind of rotation. You don't have to call out all my mistakes. I know I make mistakes. If we move on past it, we're fine. Okay? Next one, lattice model. This is just going to be, for those of you that don't really understand it, I'm going to walk through it really quick with 2 2-digit numbers. This is another really easy one to use with large numbers because you keep adding boxes for how many digits there are. So if there's a hundreds place, how many boxes would there be?
3.
They're on, let's say on a row or a column, how many, if there,
3.
okay, there'll be 3. If it's to the thousands place, how many would there be?
4.
10,000 place?
5.
Okay, etc. Keep going, and it goes both ways. Okay? So, first thing that you're going to do is you are going to take these two numbers and multiply them together to get a number in this box. If it's a single digit number, you're going to put a 0 in the 10 spot, and then whatever the number is. So in this case, 2 times 1 is? Okay. Then over here, you are going to multiply 7 times 1. What is that number?
7.
So you put a 0 and a 7. Don't worry about the 1 yet. That's why I kind of put it up and away. 2 times 2 is? So you put a and then 7 times 2 is?
14.
So we have to put a 1 in the 10 spot and a 4 in the 1 spot. Next thing you do is you're just going to add going this way. So you start from the right. So 4 would go here. Does everyone see where that's coming from? Over here we had 7 plus 1 is 8 plus 4 is 12. We have to carry the 1 because that's another 10 over here. So that's where the 1 came from. Okay? So the 2 is here, the 1 is there. Now 1 plus 2 is?
3.
And up here we have 0, so our answer should be 324. Does that make sense to everyone?
Yes.
Are there, kind of? I can walk through it individually, otherwise I can reference you to this slide. Does anyone have any questions on the different models? Okay, like I said with the packet, I'm just going to pick one up. I'm not going to show who it is, but their demonstration has some, they did it in their head. And this isn't just, this isn't the only person that did this, trust me. It's about 75% of you wrote just a number at some point. Don't do it, the first 2 pages I don't want you to do in your head. And if you're doing repeat addition on this, in this instant, this person did repeat addition as one strategy, which is awesome. I think that's a great strategy. So 7 plus 7 was one of them. Okay? But don't use your second strategy as a different type of repeat addition. Okay? Do 2 different strategies. So maybe for 1, especially since these are small numbers, 1 could be a picture, 1 could be repeat addition. And what I'd like you to do throughout the first 2 pages is try to touch on every single one of these strategies somewhere. Except for maybe the anchor facts, because these you don't really need anchor facts for because the numbers aren't big enough. Are there any questions? Alright, you can stop it.